All right, how's everybody? Has a little tough technical difficulties, but we got that taken care of. Okay. Sorry about that. My computer was acting up a little bit. Good morning. Hey, Angela. I'll wait till everybody get on. Please have your book handy. Hello, Ari. How's it going? Still mad you're not taking my test, but it's all good. Okay. Oh, hey, look at what I tell you, Danielle. Ebonics and English. I don't know what I'm gonna do with you and my boys. One will speak 5 languages, the other will speak 3. I speak 2. Well, yeah. Hey, I'm money. Oh, Lauren, good to see you. Oh, you know what? I hate to say this, but Ananike, I miss your voice. I really miss your voice. That's crazy. Now, if we ever get back to school, I don't want you catching up on talking, please. Shadrick, you better be glad I can't hold on to you. And you know why. Okay, so we got enough people on. We're going to wait like another minute or so. If you don't quit that mess, please have your book in front of you. I'll try to write some of the stuff out of the book, but I can't write everything. You sure you're okay? All right. Okay. I hadn't had a chance to grade the test because I was teaching from 10 to like 5:15 yesterday. Then I had to get ready for today. Oh, yeah, page 416. That's what this example came from. All right. So before I started teaching, Okay. So on the block, remember, okay, if you're not a magnet student, you have electives that you have to fill out for next year. If you're a senior, this does not concern you. Okay. So I put on my blog about the instruction for the online registration for electives. Also, well, Miss Stennis, who's over scheduling, okay, so she put a link for all the elective classes that's available, okay, for the non-magnet students. Well, the magnet student, if you could talk Ms. Hurd and let you take some of those, was a list of those electives. So make sure, she said to make sure that you pick them, you be careful in what you pick because you know she's not going to change it. Okay, so the first thing they're going to say is that is what you chose, and that's it. But I put that on the blog. And so when I'm done teaching you all, I'm going. Oh, God. This is my mom. This is my mom. Hold on for a second. I'll be right back. Yeah, mom. Yeah, I'm teaching online. What you need? Oh, I just want to ask, do you think I need to put you in the house and you in big American name while I'm still good? Yeah. I need to do it now, right? Yep. Okay. It's okay. All right. Just one. All right. All right. Okay, I'm back. All right. So, what was your question? Okay. Okay. So, that's so you make sure I put on the blog your electives that's available to you for next year. So make sure you look at that, and so you do not want people to give you your electives next year. You want to be able to have pick the ones that you really want instead of just giving you what's left over. Okay, and so most of y'all are going to be seniors next. Well, all of you are going to be seniors next year if you're not seniors now. So please go there and check. It's on the blog. All you gotta do is click on that button for elective classes, and every elective class is possible is going to be on there. Okay. All right. And I also got to put on. Hey, Abigail. I also have to put on the videos for the AP exam. So again, the AP exam, if you wasn't here yesterday, the AP exam is going to cover chapter 1 through 10. I know if you go online, like I think somebody was saying yesterday, well, Mr. Brad said up to 7. Well, guess what? Unit 7 is chapter 9 and 10. Okay, so just go on the blog and just hit on that button. So because I think your elective is coming up, we have to do it online since we are not in school. So you can't do it where the teachers pick your electives for you and help you out. We can't do that because my personal opinion, I don't think we're going back to school. I think we're out for the semester. All right. So with that said, we're going to do chapter 7. I'm going to grade chapter 6 when we get off here because I gave a quiz for my honors class, Algebra 2. I have to grade that and I have to grade you all's. Okay, so I'm going to do that today. All right. And for everybody, I am okay. Okay. I'm teaching you all doing the online stuff, technologies, doing this different thing. I like it, but it's something new to me. And so I'm helping out a personal friend do some things as well. And if to benefit students that I know needs to help. So I'm okay. Okay. This technology thing is new to me. I'm glad I'm doing it. Okay. I have no idea. Okay. So they told us to put the grades in before you got out, which I have to put that in the grade book. Then I just got to grade this stuff and just just have it filed. So when they tell us to put it in the grade book, I will. And I will let you know when that's going to occur. Now, since I have all your personal emails, since you sent in your test, okay, if you've done bad on your test or quiz, I will personally email you personally and let you know, look, you need to work on this and work on that instead of just saying it where everybody will know because that's your private information. Okay. All right. So, I already graded chapter 4 and 5. I just got put in the grade book. No, that's not necessary when we get back. Says we don't meet this for the rest of the year. Grades have to go in. Okay. Everybody's not just gonna pass just because of this virus. Okay. If you was failing before school was out, before they let us out, you gonna fail. Okay. So everybody think, oh, since coronavirus, ooh, girl, I'm passing. I ain't gotta do no more work. Nah, that's not how it works. All right. So, okay, so we're gonna talk about chapter 7 is gonna be pretty quick. So we will be done with this chapter tomorrow. So Friday, what's the day? Thursday. So we'll finish up tomorrow. Then on the weekend, I got homework and give you a practice test. We're gonna work on those practice tests. Practice test Monday. Okay, then we'll go over Tuesday. Test is next Tuesday. We'll be done with chapter 8 next Friday. Okay, chapter 9 is gonna take about a week, at least a week for me just teaching, because it's extremely important. All right, so with that said, we're gonna talk about, so we're gonna do lesson 7.1, 7.2 today. Okay, 7.2 tomorrow. Then we'll just start doing practice tests Friday. Well, actually, test will be Monday. Monday after we go to the last review, Monday evening. Yep, we are moving fast, my friend. I told you, chapter 1 through 6. That's the stuff that's getting us ready for 7, 8, and 9, and 10, because all the stuff will start repeating. I just got to add some stuff to it. All right. So actually, chapter 10 is going to take us maybe 2 days, because it's only 2 sections. But I stretch it out to 3. All right. So now, with that said, we have to talk about sample distribution. So sample distribution. So every chapter we do from now on is just 2 sections. We're doing a section on proportion. We're doing a section on mean. All right. So, but section 1 is going to be just sample distribution as a whole. So chapter 7 and chapter 8 is getting you ready. So once we finish chapter 8, chapter 9 and above is college statistics. Now, so you have your definitions, and the definitions, I wrote them down, but if you want to look at the definitions, they're on page 416. So you have what's called your parameter. Parameter is just going to describe your population. So here, your parameter is a number that describes the characteristic of your population. Remember, I told you a while back, the statistics is just a fancy word for your sample. So your statistics, it's a number that describes the characteristics of your sample. All right. Then you have what's called sample distribution. So your sample distribution, that's the distribution of values taken by the statistics and all possible samples of some of the same size from the entire population. All right. So then you have what's called your unbiased estimator. So if your unbiased estimator, if you take a sample and you do it several times and you line it up, remember how we do a dot plot? So your dot plot can represent how many times you took that sample of the same thing, of the same size, over and over again for the entire populations. And when you do that, that's going to give you a dot plot, but it's going to give you, let you know if the curve, it's going to give you the distribution of the curve. So it may be normal or maybe skewed, but if we make the sample size big enough, it's going to always be normal. Okay, so we have your parameter describes your population, your statistic describes your sample. Okay, your sample distribution is going to be, when, let's say if I take a sample size of 20 of something and I do it like 500-600 times. Okay, when I do that, make a dot plot of each time I find that proportion or find that mean, I'm just gonna make a dot plot. We're gonna see that in just a second. But before we do that, this is on page 416. Say Gallup poll asked a random sample of 515 U.S. adults whether or not they believe in ghosts. Of the respondents, 160 said yes. What's up, man? All right, now your population in this case is going to be the U.S. adult citizens. All right, that's your population. But what is your population describing? So your parameter is going to describe this population. So what is the population parameter describe? It's going to be the adults that believe in ghosts. Now your sample is going to be the 515 adults. And your statistics is going to be the 160 of the 515. And so this is going to be your P. This is going to be your event. So your statistics is going to be to say yes. And so that's going to be what they say in the book. What was in the book? So that would be what the sample proportion. And that was what they said. What was that value? It was 31%. So this is your breakdown. Okay, so the reason why they talk about your population, parameter, sample, and statistics, because when we get to chapter 9, we're going to do what's called a null and alternative hypothesis. So your null alternative hypothesis is going to be your parameter. So it's going to be talking about your population. And then we actually do the problem. We're going to be talking about the sample, which the sample is going to give you your results of your statistics, which is going to be your population. Okay, you said if you read the problem, if you go to page 416, they told you that you had 515 adult citizens, whether you're going to ask them if they believe in whether or not they believe in ghosts. So this is going to be your sample. So you talk up Gallup poll means the population. Anytime you see the word Gallup poll, that means your population. Ask a random sample, so the population of U.S. citizens, whether they believe in ghosts. So doing a population of the U.S. adults that believe or not believe in ghosts. So your population is the U.S. adult. Your parameter, which describes your population. In this particular case, what you're doing is with this U.S. population, adult population, you asking them, do they believe in ghosts or not? Okay, now, so you got a sample of 515 adults. If you want to see if of those 515 that you randomly picked, so that's going to be the sample that you pick from. Now, this sample, your statistics is going to describe what your sample is. So your sample is the event that they said yes. Okay, so out of the 515 samples, 160 said yes, they believe in ghosts. So again, you have to read the question, figure out what the population of the problem is talking about. Okay, then you got to describe why they're using the population. Then you got to say to yourself, well, what's the sample? So you got to find that sample. Then you're gonna look for, if they give you, this is your sample, they give you 160, so that's a proportion, isn't it? Or a ratio, a fraction. So anytime you do a fraction, that's just a proportion. So this statistic is going to describe the sample that you chose from 515. Parameter describes your population. Statistics describes your sample. So you got those 515 samples. So what was your outcome for those 515 adults who believe in ghosts? So your outcome would be that 31% of them said yes, they believe in ghosts. So that's describing your sample of 515 that believe or do not believe in ghosts. No, parameter describes your population. Do 160 describe your population? Look, if you were to do this right here, if I'm doing your sample proportion, this is going to be your outcome. This is your N. This is your sample size. Sample size of 515. That's what N is. And N is your success. So you're trying to find the event that they said yes. So remember, your event is going to be what you're looking for out of your sample space. So 515 is your sample space. It can't be your parameter because this is not the population of all adults. Again, parameter describes population. Look here, parameter is a number that describes the characteristics of the population. There's no way this is a population. Okay, so this is a number, but the number is the U.S., all the U.S. citizens. We don't know exactly we can approximate what the population is, but when you do a problem, they may say the population of 100,000 students or 1 million students. That's going to be your parameter, but the U.S. adults, that is a number. So the U.S. adults, that is a number. Okay. So it's going, sometime it may have an actual number for the population, or this is here. So this is gonna, if you pick something, especially if you pick something, isn't that the population? That's a total, and the total is a number. Okay, so you can read the example B, and also give you description of what's the population. So it's a temperature problem. What's the population? What's the parameter? What's the sample? And what's the statistics? Okay. All right. So now we have to talk about your sample distribution. And your sample distribution, so I'm going to go ahead and erase this. And when we get to chapter 8, and especially when we get to chapter 9, you will understand the difference between your parameter and your statistics. All right. So we got to talk about your sample distribution. Okay, so sample distribution is a distribution of values taken by the statistics, which is your sample, and possible samples of the same size from the same population. Okay, so in other words, if you go to page 419, and they talk about, so go ahead and read page 4 on page 14 on the top in green, that example of your sampling distribution. All right. So you read this, so you know if you have your book, you know what it looks like. All right. So we'll have something like so. Okay, but in the middle was what? Was 5. So I'm just gonna do this. I know it's not what in the book, but we're just going to just do something like such. These are dot plots. All right. So what they did was all these are samples of 20. So this is n equals 20. This is n is equal to 20. All these are n equal 20. Okay, so all the dot plots equal n is equal to 20. All right, so this is also, they took 500 simple random samples. In other words, they kept it fair, of size 20. So when they did it, this is basically what it looked like. So this is every time they took a sample, found a proportion. And so they did, so these are all the numbers, but what they did is converge to it's almost a norm distribution. But if you look over here, this 0.15 is away from, it's a little away from the curve, from the shape of the data. So it's approximately symmetric. Okay, but the question, if you read the question, they ask you, is it a sampling distribution? But remember, the sampling distribution means that you took a sample size 20 for all the possibles. So it may be, but this is a simulation. So it may be more than 500 it may be more than, okay, so 20 times 10, so that'd be 10. So it may be more than 10,000 in the population. So they didn't say this was all the possibles. They just said this was 500 random samples. So since they did not say it was all the possible sample size of 20, so that means it's not a sampling distribution. Now, if they was to write in the example and they said it was all the possible sample sizes of 20 of the sample, let me rephrase that. So if they said that you had all possible samples of size 20 for the entire population, it would be a sampling distribution. But since they just said 500, they didn't tell you that this was all the possible samples of size 20 for the entire population. So therefore, although we did this 500 times, it's not a sample distribution. Now, but this problem here is what's called the unbiased estimator. Okay, so all right. So but this is an unbiased estimator. The reason why it is an unbiased estimator because they start off and told you the sample proportion should be 0.5. Okay, because if you look here, this is 100, this 100 red, 100 blue, and you have a total of 200 chips. So this is going to be half of the 200 chips. So what you did was you did the 500 samples, and when you did it, it's symmetric, okay? It's going to be a mound shape, symmetric, in the approximate mean for all these samples is going to be 0.5, which is, they told the sample red is 0.5, so they're equal to each other, so it's an unbiased estimator. Now, let's say if I did all these samples and the mean was like 0.7 or 0.6, it wouldn't be an unbiased estimator. So your population proportion, and when you do a sample of many different sample sizes, do a dot plot. And when you do the dot plot and do it, in this case, 500 times or 200 times or 100 times, can record what your proportion is going to be. If your proportion, sample proportion, when you've done this several times, is equal to the population proportion that you're looking for, that was given from here. So if that's true, that means an unbiased estimate. And we'll do some more problems to see what that is. So the next thing I want to talk about is we want to talk about your, we're almost done with this section. All right, so go to page 425. And we're going to talk about your variability of a statistics. All right, so that definition is, so what this definition, I'm going to read the whole entire definition, but I'm going to tell you what it means shorthand. All right, and you, when you read it, so everybody read, so this is on page 425. I want you to read it right quick, give you a minute or so. Okay, all right, so we're back. Okay, so I'm gonna read the definition for variability of a statistics. So it says the variability of statistics described by the spread of its sampling distribution. This spread is determined primarily by the size of the random sample. Large samples give smaller spread. The spread of the sample distribution does not depend on the size of the population, as long as the population is at least 10 times larger than the sample size, which basically is your 10% condition rule. So your 10% condition rule also is going to determine if the data is independent or not. Okay, now, if the data is not independent, you can't use the standard deviation. It's basically useless. Because if your data is not independent, you don't want to use it because you want your, when you're doing your experiment, anything you're doing, you want it to be independent, because it's not independent. That means it's dependent on something. So you're going to see in a few minutes that your 10% condition rule has to be met before you can use the standard deviation properly. And remember, we talked about standard variability is just your standard deviation from the mean. And all right, wait for some feedback on this. So the variability of statistics is basically talking about your 10% condition rule. And your 10% condition rule is going to let you know two things. Your data is independent. And since your data is independent, you're able to use your standard deviation. And we're going to see that in just a second. All right, need some feedback. Also, I'm getting ready to rate this. Okay, good. So if you want to write this down, it's some good stuff to write down. It's absolutely outstanding. Okay, now, so go to page 426, and so we'll do that, and then we'll be done with lesson 7.1, and lesson 7.2 is not going to take that long because a lot of stuff we've already done. So this is crucial to understanding the rest of this book. Now, again, AP exam, if you weren't here yesterday, it's going to be open-ended only. You'll be able to take it in the convenience of your home, and it's all open-ended, and it stops at chapter 10. And so when I give you these, and so you need to be doing the AP Central online courses that I'm assigning everybody. Either you take an AP exam or not, you need to be doing them, because I promise you, you heard Maddie tell you in class, if you learn my statistics, learn it now, it's going to be very easy in college. Okay. So she did not, and my previous students did not have the access to actual AP exams. So that means you all need to step it up to another level. Okay, so yes, the next test is next Tuesday. All right, now it might be Monday. It depends. All right, so I'm going to erase all this. And everybody has played throwing dots before. Oh, I need to make this smaller. Okay, so let me ask you something. Okay, so I'm gonna take some data, and I'm playing darts, so I got All right. So if I'm looking at this one, all right, so ideally, if you're in the very center, that's going to give you, so let's do this one. So if I'm doing this one, so your ideally you want low bias and you want low variability. If you're doing an experiment. So you want the lower your bias is, okay, this is you playing darts. Okay, so if I'm playing darts and I'm throwing darts on the dartboard, okay, it's just like if you're doing an experiment, ideally you want low bias. You can't get complete bias, but you want as low as possible, so that making it as fair as possible. And then if you do this one, you want low variability because all your outcomes are right next to each other, and they're in the very center. Because if you're at the very center, you can just say to yourself you're on point, right? All right, now, so I'm gonna let this one be 1, 2, 3, and 4. So I want somebody to tell me what 2 is going to be. I wait for an answer for number 2. So what is 2? You said 2 is high variability? What about your bias? You said low bias and high variability? All right, how many people feel that way? Say yes or no. Oh my God. If you're looking at this, Angela, and if you're playing darts, this is where you're ideally trying to be in the very center of this, right? So all these numbers are right next to each other. Okay, so wouldn't that be low variability? But ideally, if you're in the very center of this is complete bias. So the further you went, okay, so if you're looking at this, okay, the further you're away from the very center of this, the more bias you're gonna have. It's that simple. All right. So what about number 3? So number 3, you got what type of bias and what type of variability? Got to remember, the further you away from the target, the more bias you have. So what's 3? Thank you, Angela. You are absolutely right. Because the variability in this data is very low, but you further away from the target, which is your bias, the very center of your target. So you have high bias and low variability. Now, being that politics is going on right now, a lot of you ask they do. Okay, yep. So a lot of times, the reason why you need to know statistics very well, and a lot of people don't take the time, they think statistics too hard. Actually, the sad thing about it, some math people think statistics is useless, which that's so stupid to me. Now, so a lot of times you don't know your statistics. Somebody can say, well, the variability is low, it's real low, so therefore it works. But they may have high bias. That could be so. But if you know statistics, the minute they start talking and you're looking at the data and they explaining stuff to you, you will know for sure that although they can talk about the variability is low, you can listen to them and see that it's high bias. Now, if I'm looking for 4, what's going to be the deal with 4? So we know that bias is what? What's going on with the bias? Yep, you got high bias because it's further away from the center, and this is spread out. You can think about correlation. If you got your correlation is more spread out, so that's going to you also have high bias. I mean high variability. I'm sorry. So ideally, this is what you want. You want low bias and low variability. And so when you do stuff, you don't want low bias and high variability. So I'm not being biased, but your variability is high. So if you're doing here, you got low variability. That's normally people that like to lie all the time. Oh, the variability is high, and then they know that the bias is really high. Just like people running for office, if you're Democrat or Republican, everybody gonna be doing their stats to make sure what they're looking for, the variability is low and the bias is high. And some of the politicians are gonna do their best to be the fair ones. Okay, so we're done with section 71. So ideally, again, you want the low bias, lowest as possible, and you want the variability low as possible because the more low variability is going to give you you're going to have more accuracy. Then low bias is going to make it very fair. And that's what you want ideally for something, even if you like something or not. You want it to be fair. Maybe you may disagree with it, but at least it's fair. And then you want it to be as accurate as possible. So you don't want stuff to be accurate, but yet it's highly unfair. And you don't want something to have highly unfair and also have a lot of variability in it. You do not want low bias but high variability. All right. So that's section 7.1. Now we got to talk about section 7.2. All right. So now everything we do from this day forward is going to be either a proportion problem, which is a ratio, or a mean problem, which we're going to find the average. So we're going to talk about proportion today. All right. Now, so if you go to page 436, that's where I'm getting this stuff from. 436, page 436. And you have all your rules for proportion. And I hate to burst your bubble, class. We supposed to be on this chapter 7 about 2 weeks ago. But I like you all, so I slowed it down a little bit, but can't do that anymore. All right, now. So the things you need is you need your population, you need your sample size, you also need, so you got to remember that you have your population, and I'm going to tell you what it means in just a second. And then you have your, so let me do this here so I have room. All right, so that's everything you would need for your sample proportion. You need your population, so it's going to be given to you directly or indirectly. You have your sample size will be given to you. Oh, I guess I need to get rid of this. You have your sample size is going to be given to you. This is your population mean of your sample proportion, which is P. Okay, remember we did the insurance problem where everybody had the same exact policy. And so if we did it for 3 policies, it was just a 3 divided by all of them. And then if we had 4 policies, it would be the 4th policy divided by 4. So when they did the insurance policy, they was introducing you to this. Okay, so this is your population mean of your sample proportion, or you can simply just write P. It means the same thing. This is your population standard deviation of your sample portion. So make sure you see this and read this perfectly, because when we get to chapter 9, it's going to be it's going to be the same thing, but the symbols are going to change. Okay, so this is your population mean. So I'll write in words. Population mean of your sample proportion. That's how you would say that in words. Then this would be your population standard deviation of your sample proportion. Now, again, your population, your standard deviation can only be valid if the 10% condition rule is being met. Now, if you have this data, you can only use the norm curve, the z-score formula, which is the norm curve, you can only use you can only use the norm curve when your sample size times your proportion is greater than or equal to 10, population proportion, and your sample size times your 1 minus your proportion, which is just your failure. It's both are greater than 10. So this is what we're looking for, and this is out of the sample, the success out of the sample. So that's all you need for your sample, not sample proportion, just sample proportion. I'm sorry. Should be your sample proportion. That's all you need. Okay, so we're almost done. All right, so if you go to page 478, all right, so they're talking about in this, so go to page 478, and I need you to read that, and then I'm going to come back and we'll talk about it. All right, so I'm hoping that you read it. Okay, so if you read it, remember you got your population, you got your sample size, you got your population mean or your sample proportion, which is just P. Then you have your standard population standard deviation of your of your sample proportion, which is this, this is only valid if the 10% condition rule is being met. All right, now, so what we want to do here, so we read the problem. They told us that the first year United States college students, so they talk about from home, right? Within home. All right. So I'm sorry. So your population is the first year, your first year college students. Now your parameter would be students that's away from home, right? Okay, now they told us that the sample size was 1,500. Okay, and the proportion in this case was 35. That was the population proportion, which is you could put P or you could put the population mean for your sample portion. Then you have falls within 2% of your true value. So we know if the sample size is going to be 1,500, and so that means that so we're going to test for see if this is valid. Okay, so we know by the 10% condition rule. Hold on. So we should know that N is going to be great. This is all the U.S. first year college students. We know 10 times 1,500. So N is going to be, that's going to be 15,000. Now we know without a doubt that we have more than 15,000 first year students. All right, so the 10% condition rule is being met. Okay, so if this is being met, the standard deviation is valid. In other words, we can use it. All right, so we could go ahead and so we know that this is we know this is going to be 35. We already got that because they gave it to us in the problem. Now we got to find the standard deviation of your sample proportion. So that's going to be P, in this case is 0.35. And if I do the complement of that, that's 0.65. And then the sample size is 1,500. So they gave us in the book, what was that? 0.123. All right, so this is valid by the 10% condition rule. Okay, now we're going to test for normality. So normality, we have to make sure that you got to make sure that N times P is greater than or equal to 10. And you got N times 1 minus P is greater than or equal to 10. So that means we're going to do 1,500 times 0.35. And we know that's going to be greater than or equal to 10. And then if this is 35% of 1,500 is greater than 10, we know for sure that 1,500 times 0.65 is also greater than 10. Now, if you want to, they told us in the book that what was it? We do multiply by 10. That was what, 525. So this was 525, and this was 975. So we know both of those are good. So all that is true. All right. So since that's true, we could come over here and we can find the answer. So we know the 10% condition rule is being met. So that means this standard deviation is valid. Then we test for normality for proportion. We saw this was true. So now they want us to find within 2 percentage points. So basically what they're saying is looking for the probability that the probability that your sample proportion is going to be between, so if I do 0.35 plus 0.2, that's going to give me 0.37. If I subtract this by 2, so that'll give me 0.33. Now, if I want to, since I know it's normal, I can use the normality, the z-score formula. So I'm going to put z here in the middle. So this is my sample proportion. And so I'm going to do 0.33. This is my population proportion. 0.35. And the sample population sample standard deviation is 0.0123. Come over and do the same thing for this. So my sample proportion is going to be 0.37 minus 0.35 all over 0.0123. So, all right, so let me see, what did it give us for the z-score? All right, so we had a negative 163. So this should be a positive 163 since they're equal distance. So when I look this up, do my curve, all right, so I got what, a negative 163. So that's going to be about right here. And I had to find this area up under this curve. Then I got to go up here. 163 is about right here. Then I have to find that probability. And then, but we're looking for this area right here. So what did they say? A negative 1 point. So we had what, a 0.0516. Then for here, that should give us what, 0.9484, I think. Is that it? Yep. Okay, so now you want to find this area right here. We simply going to do 19484 minus what's that, 0.0516. Basic math, so that's 7, 1. Got a bar from here, that's 8, 14. So that's going to give us what, 8, 6, 9, 8. All right, so we have about 89.68% of first year students So we have about 89 point, or you can say about 90% of the U.S. students that live within 50, I think what's that was within 50 miles of their home. Yep. Any questions? Any questions? So again, they're going to give you your population mean for your sample proportion. They're going to give it to you in a number, or they may say that you're going to, so you got a sample of 15, like we did the first example of the U.S. citizens. We had 515 that was you want to sample to see if they believe in ghosts or not. Out of that sample, 160 said yes, so that will be your sample proportion. All right, so do we have any questions on this? Okay, you have your population. They're going to give you your population mean for your sample portion. They're going to give you your sample size. So this is going to be given to you. Then you got to use the 10% condition rule to make sure that the population standard deviation for your sample portion is valid, because you can always find this number, but can you use it? You can only use it if the 10% condition rule is being met, because the 10% condition rule let you know that your data is independent, and that's what you want. You never want data that's not independent, okay? Because that's one of the rules for checking for your data. Your data has to be random, and you're going to find out later, has to be random, has to be independent, and what's the other one? It's one more. And normality. Those are three rules we're going to use from everything we do from this day forward. Okay, randomness, independence, and normality. So you use normality strictly see if the population is valid. If the population is valid, it's independent. Your data is independent. Then for test for normality, for proportion, we got another thing we're going to use for when we do mean tomorrow. If n times p, or think about it this way, if your sample size times your population proportion is greater than or equal to 10, and your sample size times your failure, your population failure is greater than or equal to 10. If that's the case, then you can standardize your data and find your proportion by using a norm curve. Okay, are there any questions? If we do not have any questions, that is lesson 7.1 and 7.2. I need some response so I can log out of here. Okay, good job. All right, no questions. All righty then. Okay, so what I'm gonna do once I get off with you all, I'm gonna go ahead and put the problems on the blog for the rest of the week. Okay. I hadn't heard from you, Riri. Are you on here? Okay. All right. See y'all later.